valid parenthesis problem where we will be given a string containing the characters, the parenthesis characters, and we need to determine if the input string is a valid parenthesis. An input string is valid parenthesis if the open brackets must be closed by the same type of brackets, the open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. For example, if you see in this example, this type of bracket is closed with a corresponding opening closing bracket, so is this square type of bracket. Similarly, here also we can see that for every opening bracket there is a corresponding closing bracket in the same order. For example, in the case of an invalid string of parentheses, we can see that there is a set of opening brackets but there is no corresponding closing bracket. For example, this particular one does not have a corresponding closing bracket. Here also we can see that we have a set of opening brackets and its corresponding set of closing bracket, but we have an extra closing bracket which do not have any corresponding opening bracket. So this is an invalid set. Now, how to find? So we can see that every opening bracket is closed by the corresponding closing bracket in the same order as the opening brackets. So we can use that property to solve this. Before that, we need to create a dictionary or a hash map with every opening bracket mapped to its corresponding closing bracket, so that it will be easy for us to see if we are getting the correct opening bracket and the corresponding closing bracket in the same order. Now, to solve this problem, we are going to use a stack structure. A stack is a linear data structure that follows last in first out, a LIFO principle. That is, the last element added to the stack will be the first one to be removed. How we are going to use is that, suppose in the case of this valid parenthesis, let's take the biggest one so that it will be easier for you to understand. We are encountering, so as we are traversing through the string, we are encountering an open bracket, so we will immediately add it to the stack. Now again we are encountering an open parenthesis, we are again adding it to the stack. Again we are having an open parenthesis, we will add it to the stack. Okay, now as we move to the next character in the string, we can see that it is a closing parenthesis, so we will pop out the last element that is added to the stack, that will be this particular one. We will pop that out means removing it from the stack, and compare it with the element that we have just encountered. So if we will see that if this opening closing bracket that we just popped out of the stack is the corresponding opening bracket of the closing bracket that we have just encountered, so we can see that it is. Then we will move on to the next one. It is again a closing bracket of this kind, so we will again pop out the last element in the stack, that is this element, and then we will compare it with the current element that we have encoded if it is the same mapping, for which we use the dictionary. We will see that if this popped element has this as the key value, which is this one which we encountered here. Now again we are encountering a closing bracket, we will pop out this from the stack and see if it is corresponding to the closing bracket that we have encountered in the traversal of the string. So we can see that all of these strings throughout the entire string that we have traversed the entire string, and then we found the corresponding closing brackets from the stack. So now the stack is also empty and we have traversed the whole string also till the end, which means that the string is a valid parenthesis. So we can conclude that if the stack is empty and we have traversed the whole string, then the string that is input is a valid parenthesis and we have to return true. Now what happens when we have an invalid parenthesis? We have two cases to consider here. Let's go one by one. So we are encountering a opening parenthesis which we will add it to the stack. Again we are encountering a opening parenthesis which we are again including in the stack. Again we are having a opening parenthesis, we are including it in the stack. Next is a closing parenthesis. So what we will do, we will pop out the last element from the stack, that is this parenthesis, and then we'll compare it with the closing parenthesis that we just encountered. So these are not the same, which means that we have encountered a closing parenthesis that is not in order of the opening parenthesis, which means that this particular string is not a valid parenthesis, therefore it is false. Okay, now we have another case, this particular case. Let's see that. In this case, okay, let's traverse to the string. Again we encountered an opening parenthesis, yes. Again an opening parenthesis, yes, yes. Again an opening parenthesis, yes. Again a closing parenthesis, so we will pop out the last one. Okay, so that is the popped out one. This is the encountered closing parenthesis. They are same as in the correct matching pair. Again we will move on to the next character in the string, that is this closing parenthesis. We will pop out the last one from the stack and we will compare it with the one which we have encountered. They are matching. Then again we have a closing parenthesis, we will pop out that one and compare it with the one which we have encountered. So they are matching. Now again we are moving on to the next character in the string. So the next character in the string is a closing parenthesis. Then when we go into the stack and see that it is empty, which means that we do not have a matching opening parenthesis for this particular closing parenthesis, which means that this string of parenthesis is an invalid string of parenthesis, which means that we need to return false. So these are the two conditions where a string of parenthesis will be a false string of parenthesis or invalid string of parenthesis. Now let's see how we can code this out. Okay, cool. So first we need to initialize our stack. Okay, this is the stack which will contain the opening parenthesis. Then we should have a dictionary hash map. Let's copy it from the notes, which will be easier. Okay, we have everything, the three type of parentheses that is guaranteed to be appearing in the string. Now for parenthesis, let's keep it that way. Parenthesis in the given string s, if parent is in this list of opening parenthesis, that is we are seeing if the encountered character in the string is an opening parenthesis, then we need to append it to the stack. We are adding it to the stack. Else we are encountering a parenthesis in the closing type of parenthesis. Okay, if the one which we have encountered is of this type, and we also have to see if the stack is empty, because if the stack is empty, then also it is a condition for false. And also we cannot stack out or pop out of an empty stack, so we need to check this condition. Only if this condition is true, then go inside this and pop out, otherwise it will throw an error. If h of stack dot pop, this is the function to pop, is not equal to the path, that is if they are not matching. This we are popping out the closing bracket and checking it against this. If they are not equal, then we know that it is not a valid parenthesis. Else, what is the other else condition that we can have to make a parenthesis false is for the stack to be empty before the string is empty, before we completely traverse the string. That is also a condition where the stack can be empty. So by the end of this for loop, if we have not encountered any false condition, then we will reach the end of the string that we are traversing, which means that only then we need to check one condition. If length of the stack is empty, length of the stack is 0 means the stack is empty, return true. Let's run it and see. All the test cases are accepted. See, and then submit. Cool. Here the time complexity will be O of n because we are traversing through the entire string, and space complexity will be again O of n by 2, which will be transferring it as O of n because we are only storing half the string in the stack. That's it.